Hello students. Today we are going to talk about lesson 7.4, expanding algebraic expressions. Expanding algebraic expressions is simply another way to simplify algebraic expressions. So let's look at the first example up here on the board. 2 parentheses r plus 8 parentheses. Following our order of operations, we know that we need to do what's inside the parentheses first. So let's see if we can simplify anything inside the parentheses. R plus 8. Well, we don't have any like terms in the parentheses, so it seems like we're stuck here because we can't simplify r plus 8, and therefore we can't move on to multiplying it by 2, right? According to our order of operations, that seems to be the case. However, there's something here that tells us we actually can do this and make it a little bit more simple than what's up here, okay? R times parentheses, 2 times parentheses. This simply means that the 2 needs to be multiplied by the r and the 8, both of them. And we can actually do that without having to simplify what's inside the parentheses first. So I'll show you how. It's like taking the 2 and putting it inside here. So 2 times r and 2 times 8. Let's look at that with just some numbers and not have any variables in there and see if it makes sense, if it works with just numbers in the parentheses instead of variables in there. So our first one, we have 2 parentheses. Let's do 6 plus 8, right? So we can do this. Let's do this following our order of operations first. So 6 plus 8 is 14 times 2 equals 28, right? 2 times 14 equals 28. So we did our order of operations. We did what was inside the parentheses first, and then we multiplied that by 2. Let's do it this way though. I'm gonna rewrite this, 2, 6 plus 8 parentheses. Okay, so this simply means 2 times everything that's inside the parentheses. So we can do 2 times 6 and 2 times 8. So 2 times 6 is 12, and we still use our symbol here, plus 2 times 8 is 16. And then 12 plus 16 equals 28. So we get the same answer no matter which order we do this in, so to speak. We're still following our order of operations. We're still applying our order of operations, but we can distribute is another word we could use, or we can expand this expression by distributing the 2 to each one here. So let's go back to our original one. 2 parentheses r plus 8 parentheses. So we want to take our 2 and distribute it. We want to give it to both the r and the 8. So if we take 2 parentheses, remember this is just another multiplication, way to write multiplication. So this means 2 times r, 2r, plus 2 times 8, 16. Okay, this is what we call expanding algebraic expressions. We've taken the 2 and we've distributed it to everything inside the parentheses. If there were 16 different terms inside the parentheses, we could distribute that 2 to every individual term in there by multiplying it by 2. But it equals the same thing. These are equivalent expressions because we've distributed the 2 to each. All right, that's really strange in numbers or in math. So I'm gonna give you a physical picture of what's happening here. We'll see if it works. I actually haven't tried it yet, so we'll see what happens. But what I have for you here are sprees, which are candy. They're kind of like sweet tarts, but they're chewy, not hard, right? So I have a red one, and the red one has an 8 on it. I have an orange one, the orange one has an R on it. So these are representing our 2 numbers up here. And then I have a little cup here, or beaker, and that is representing our parentheses. So I'm gonna put them in there so you can see the tops. I'll show it to you better in a minute, but I put them both in here. Okay, the last thing I have that's gonna represent our 2 is some water. It's kind of warm water, so hopefully it'll help this all happen faster. But the water is representing the 2 here. So what we're gonna do is we're gonna pour this water into this beaker, and see, does it only affect one of them, the first one, which would be R, or does it affect both the red and the orange sprees that are in here? Because when we are distributing the two, it's kind of like we're pouring the two into the parentheses. So let's find out what happens. Okay, so you can see I have my R and my 8 piece in here, and then I have my warm water, that's representing 2, and I'm gonna pour the warm water into the parentheses, onto our candy. And let's see, does it only affect one? If you look closely, I don't know if you can see it on the camera, but you can see that both the orange and the red are coming off of the two colored pieces of candy. And you can kind of see they're divided in the middle, right? And so it's just a silly little example to help you get the idea into your head that when we have something inside the parentheses, right? When we have something inside the parentheses, whatever we have multiplied by those parentheses, it's going to affect both things that are in it. Okay, now I'm really fascinated by this. I don't know if you guys can tell, but the 8 is actually peeling off and the R are actually peeling off of the candies. But they're staying, like the R is, well, it's just floated around now, but it still was an R. They kind of tore. Anyway, that was fascinating. That was interesting. Oh, and you can even see there's a divide down the middle of red on this side and orange on this side of your cup. So it still looks like they're two separate things, but they've both been affected by the water that we poured in it. Okay, so kind of a silly example, but hopefully what it showed you is that if these are in our cup, if something in the parentheses is saying like it's inside a cup and we've poured the water onto it, both are gonna get wet. The R is not the only one that gets wet, right? If we pour water into a cup, everything inside that cup's gonna get wet. So the parentheses act like a cup. It holds those together. You can't take them apart. But if we're multiplying something by it, or ultimately if we're dividing something by it, then we can distribute that something to both of them, and we get 2 times R plus 2 times 8, or 2R plus 16. Okay, if you open up your textbooks, and I want you to do that now, to page 239, you'll see an example of it done with bar models. But 2 times parentheses R plus 8 means, like they say on that page, 2 groups of R plus 8. So we could also rewrite this. This is equivalent to R plus 8 plus R plus 8. Which we know we can simplify by reordering it, R plus 8 plus 8, which equals 2R plus 16, right? So this simply means 2 groups of R plus 8. We call that distributing. We want to distribute the 2 to everything inside the parentheses, to both the R and to the 8. Okay, we call that distributing the 2, and overall we call that expanding the equation or the expression. All right, let's try another one. Turn the page and look at the top of page 240. It says to expand 3 parentheses, K plus 6 parentheses. So this means 3 groups of K plus 6. So K plus 6 plus K plus 6 plus K plus 6, right? Or let's just distribute that 3 parentheses, K plus 6. We're going to distribute it, and when you're starting this, it's really helpful to draw the arrows. 3 times K and 3 times 6. So 3K plus 18, right? We've distributed that 3 to both the K and the 6. Can't leave anything out because otherwise it would not be properly distributed. But once we've distributed it like this, then it's really simple to expand our equation. Okay, go down to the guided practice. Let's look at number 1 together, and then I'm gonna have you do 2 through 6 on your own in your notebook. So number 1 says 3 parentheses x plus 4 parentheses. 3 parentheses x plus 4 parentheses. Okay, so we want to distribute our 3. We want to pour our 3 into our parentheses so that it affects both the x and the 4. Okay, so 3 times x is 3x plus, we're just going to take that symbol, plus 3 times 4 is 12. So we've distributed our 3 inside of our parentheses. Okay, go ahead, label in your notebook, guided practice 7.4, and please do problems 2 through 6. Pause the video, complete those problems, come back, watch the video, make sure you got them all correct, right? So pause your video. All right, let's solve for these. Let's expand is the word that we're gonna use, expand these expressions. So number 2, let's distribute the 6 to each term inside the parentheses. So 6 times 2x and 6 times 3. And you should get 12x plus 18. Number 3, 2 times 7 and 2 times 6x. This equals 2 times 7 is 14 plus 12x. Number 4, distribute the 5 to both the y and the 3, and we're just going to take this symbol and use the symbol that's there. We're going to take it right with us and use the symbol there. So 5 times y is 5y minus 5 times 3 is 15. Number 5, 4 times 4y equals 16y minus, because we're going to take that minus symbol, 4 times 1 is 4. Number 6, 9 times 5x is 45x minus, we're going to carry that with us, 9 times 2 is 18. All right, I think those are all correct. 5y minus 15. All right, looking good. Okay, so that is how we expand algebraic expressions. We're going to distribute the number, or it could be variable, outside of the parentheses to each of the terms inside the parentheses. Whether it's 2 terms or whether it's 26 terms, we would distribute it to every term inside the parentheses. Okay, now look at 7 through 10. 7 through 10 asks you to state whether each pair of expressions are equivalent or not. So let's look at those. Number 7, let's expand it so that it looks just like the one next to it. So 6 distributed to x, 6x, plus 6 distributed to 5, 6 times 5 is 30. So you have 6x plus 30, and you have 6x plus 30. Are those equivalent or not equivalent? Those are equivalent. They're the exact same expression, so they're equivalent. Okay, go ahead and do numbers 8 through 10 on your own. Pause the video. I'll do them on the board. All right, let's expand these to determine whether or not they're equivalent. So number 1, we're going to distribute the 7 to the x and to the 3. So we get 7 times x, or just 7x, plus 7 times 3 is 21. 7x plus 21 and 21 plus 7x. Are those equivalent? They are. Do you remember what property we call that? That makes those equivalent? It's the commutative property of addition, right? Addition doesn't matter which order it comes in. It's the same sum, no matter which order you organize the terms in. All right, number 9, let's distribute it. 4 times y equals 4y minus 4 times 4 is 16. So 4y minus 16 and 4y minus 4. Well, those aren't equivalent, right? Those are quite different. So number 9 is no, not equivalent. Number 10, 3 times y is 3y, and 3 times 6 is 18. So 3y minus 18 and 18 minus 3y. Are those equivalent? No, they're not, because subtraction does not have a commutative property. The order does matter in subtraction, so we can't switch that order around. All right, there is your introduction to expanding algebraic expressions. Remember, anything that you are multiplying the parentheses by, we can distribute it to each term inside the parentheses, and it is the same thing as following the equation that's inside the parentheses first and then multiplying it by. So think about that water. You're pouring it in and it's affecting all the candies that are in the cup. Not just one candy, not just the other candy, but all the candies. Okay? All right, I will talk to you later.